So in the previous video, we saw how to secure our microservices using the Keycloak authorization server. So now let's continue our project by introducing another component called as circuit breaker. So a circuit breaker is mainly used when we want to have a resilient communication between our services. So if you remember, we have our order service and the inventory service, and we are calling the orders inventory service from our order service using the web client, which is like asynchronous communication. So the problem with the synchronous communication is like we can have many problems while calling the inventory service from the order service. So one of the problems is like the inventory service may be not available, it may be down. That is one problem. And the other problem is like this calls we are making from our order service, like for some reason the inventory service may respond slowly to the order service, right? So by design, the remote service calls can be slow. So if something goes wrong in the inventory service, like if due to a performance issue or database issue, we can expect slow API calls while calling the inventory service, right? So when we face these kinds of problems in a microservice environment, we have to make sure that our system is resilient. We don't want the request to terminate abruptly, right? We have to fail fast, and we have to fail, and we have to provide some kind of resiliency to these kinds of issues. So this circuit breaker pattern is nothing but a set of states we maintain in our application. So let me scroll down and open this flow diagram, right? So by default, if the communication between the services is working fine, that means if we don't find any issues, the state of the circuit breaker will be in a closed state, right? So if a circuit breaker is in closed states, communication will be allowed as it is. And imagine that if our inventory service is not working as expected due to maybe temporary network issues or something, what will happen is the circuit breaker will go to a state of open. So in the open state, what will happen is, as we already know that the calls to inventory service is not working, it doesn't make any sense to keep on calling this inventory service, right? So until and unless the issue is solved, it doesn't make any sense to keep calling the inventory service like in the above example. For this reason, the circuit breaker will change to a state of open. That means it won't allow the calls from our order service to the inventory service anymore, right? So it will not allow it for the certain number of time, for the certain number of duration. We can configure it ourselves. So during this period, either it can just throw the error message, or it can also execute some fallback logic, right? So for example, if the inventory service is not available, what we can do is we can cache the response from the inventory service, and we can just use the cache, right? Maybe this is not a good idea, this is not a good example, but we can maybe try to execute some fallback logic, right? If the inventory is not available, maybe, I don't know, like we can try to execute some fallback logic, and we can execute this with the help of circuit breaker when the state is in open. When the state is in open, after a certain number of after a certain duration, the circuit breaker will change the status into half open. That means it will slowly start taking the requests from to the inventory service, and it will check whether the requests are going through or not, right? If the requests are still not going through, it will change the status to open. That means it will not allow the calls, and it will just execute the fallback logic, right? And if the requests are executed successfully, then it will change the status of the circuit breaker back to closed. So this loop will be followed like whenever we are making the calls to the inventory service from our order service. So as you saw this theory, now let's go ahead and implement this circuit breaker logic in our project. So to implement this logic, we don't need to write the logic ourselves. We have a library called as Resilience4J, which will help us with the circuit breaker logic. So I can open the website of the Resilience4J. So this is a lightweight, easy to use fault tolerance library, which is inspired mainly by Netflix Hystrix. If you are aware of the microservices landscape, we used to mainly use Hystrix as the fault tolerance library. So Resilience4J is mainly like a newer alternative to Netflix Hystrix, right? So we can make use of this library in our project by using a Spring Cloud project called as Spring Cloud Circuit Breaker. We'll be mainly using this project to implement the fault tolerancy using the Resilience4J. So if you see, Spring Cloud Circuit Breaker can have multiple implementations. One is with the Netflix Hystrix, Resilience4J, Sentinel, and Spring Retry. We'll be mainly using Resilience4J in our project. So I'm inside the IDE and I'm going to open the order service, as we are going to mainly implement the circuit breaker pattern inside the order service. So for this, I'm going to first add a dependency called as Spring Cloud Circuit Breaker. So for that, I'm just going to add another dependency just below the Spring Cloud Starter Netflix Eureka Client dependency. I'm just going to copy this dependency and change the artifact ID to Spring Cloud Starter Circuit Breaker Resilience4J, as we'll be mainly using Resilience4J here. And after that, we also need another dependency called as Spring Boot Starter Actuator. So for that, I'm just going to change the artifact ID to Spring Boot Starter Actuator, and also the group ID to Org Spring Framework Cloud to Org Spring Framework Boot. And yeah, so once I added this artifact ID and the group ID, the Maven dependencies will be downloaded by clicking on the Maven icon if you are using IntelliJ. So once we have added these two dependencies, we can go ahead and configure Resilience4J in our project. So I'm going to open source main resources, application.properties. And the first thing I'm going to do here is first to enable actuator, right? So using actuator, we can have a look at different kinds of health metrics for our application. So for that, I'm going to type in management.health.circuit breaker enabled equals true. So first I'm going to enable the circuit breakers endpoints in the actuator. And after that, I'm also going to type in management.endpoints.web.exposure.include, right? So for this, I'm going to type star so that our actuator will expose all kinds of endpoints. By default, it will only expose the health metrics endpoints. So I want all the endpoints to be enabled to us, right? So for that, I've just provided the value star here. And I'm also going to type in management.endpoint.health.show details. So the health show details property is by default set to never. So we're going to always show the complete health details of our application. So that's why we're going to use this configuration. And now we can go ahead and define the Resilience4J properties. So for that, I'm going to type Resilience4J properties. And for these properties, I'm just going to copy and paste some properties so that you don't watch me type all these properties. I will just explain what are these properties and why we have to use these properties, right? So the first property is called as Resilience4J circuit breaker instances inventory and register health indicator, right? We want to register a health indicator so that we want to see the different states of circuit breaker. We have mentioned before, right? The circuit breaker maintains different kinds of states: closed, open, and half open. So to be able to see those states, we have to first register the health indicator for our Resilience4J library. So that's why we provided this property as true. Then after that, we also have to provide an event consumer buffer size as 10. So that means how much buffer size it is going to take for the events. We have to provide it as 10. And after that, what our circuit breaker will do is it will make sure that it won't open the circuit breaker right away, right? So if Resilience4J understands that a call to the inventory service is failing, it won't change the state from closed to open right away, right? It will wait for some number of requests to fail. Like for example, if only 5 requests are failing, if only 5 back-to-back requests are failing, then only we will change the state from closed to open, right? So to be able to count this number of requests, we have to provide the sliding window type as count based, right? So Resilience4J will use a sliding window algorithm to be able to determine when to close and open the state of the circuit breaker. So for this, we have to provide the sliding window type as count based, right? And the sliding window size as 5. That means after 5 failed requests, the circuit breaker will try to change from the closed to the open state. And the failure rate threshold is be 50%. That means when the 50% of the calls are like failed, then the rate threshold, we are setting it as 50%. And after that, we will also configure how much time we can wait in the open state, right? Before going to the half open state, we don't want to allow all the calls, we have to execute the fallback logic. So for this, we can configure the Resilience4J to wait for 5 seconds in the open state before changing to the half open state, right? So the next property is permitted number of calls in half open state, right? How many calls we have to allow in the half open state so that Resilience4J can check whether the communication between our order service and inventory service is working fine or not. So this is going to be 3 calls. We will allow only 3 calls in the half open state. If the communication is still failing, then Resilience4J will change the status to the open, right? Like how we see here, when the circuit breaker understands that 3 calls are failing, then it will change the status to the. So, and lastly, we are also going to configure the property automatic transition from open to half open enabled. It's true. So we want to automatically transition, like enable the transition between open to half open. After adding all these properties, this is the only thing we have to do after configuring these properties. Next, what we can do is we can configure our code to make use of this circuit breaker. So we'll see how to do that next. All right. So to add the circuit breaker logic to our code, I'm going to open the order controller. This is the place where everything starts, right? Whenever we are trying to place the order, the request goes to the place order method inside the order service, and inside the order service we are actually making the call to the inventory service here, right? We can also add the circuit breaker logic inside the order service, but just for my convenience I'm adding it to the order controller, right? So about the place order method, I'm going to type annotation called as circuit breaker. And to this circuit breaker annotation, I'm going to provide an attribute called as name. So this name, I'm going to provide it as inventory, right? So what this will do is Resilience4J will apply the circuit breaker logic to this particular place order method, like whatever API calls which are being made inside this place order method call, it will apply the circuit breaker pattern here, right? So this is all you need to do to implement the circuit breaker pattern in your project. So one thing we also understood is we want to also implement a fallback logic whenever the calls are failing, right? Whenever the circuit breaker is in the state of open. So for this reason, as a fallback logic, what we can do is we can provide a fallback method to the circuit breaker annotation, so that whenever the circuit breaker understands that they are failed calls, it will just execute the fallback method, right? So for this, I'm just going to add another attribute inside the annotation called as fallback method, and here we have to provide the name of the fallback method. So for this, I'm going to provide the name as fallback method, and what I'm going to do is I'm going to create another method with return type as string, because we need to have the same return type as the original method, and I'm going to provide the name as fallback method, and I'm also going to make use of the same method signature. We'll take an order request, and additional to that, we also have to add another method parameter called as runtime exception, because whatever exception is raised from this particular method, from the place order method, will also consume this exception into the fallback method. So in here, I'm going to return a status message, something like, oops, something went wrong, please order after some time, right? We are going to provide this particular error message. So instead of showing something called as a runtime exception, or maybe timeout, or HTTP status failed, some exception, we can just provide a good error message to the user. So this fallback method will be executed by the circuit breaker. So now it's time to test our implementation, whether the circuit breaker is working fine or not. So for that, I'm just going to start all my services. Also make sure you start all services, and let's start testing in the next step. So all my services are up and running. I'm just verifying everything is fine or not in the Eureka portal. So everything is working fine. So now I'm going to open Postman, make a call to the order service, and let's see what will be the response. I'm just going to first make sure that I have a valid access token. So I'm just going to click on get new access token and click on proceed, click on use token, and I'm going to send this request. And you can see that we have received the status as order placed successfully, right? This is perfect. So now what I'm going to do is I'm going to stop the inventory service, right? Just before stopping the inventory service, I'm just also going to show you the status of actuator by typing localhost 8081/actuator/health. And here you can see that we have the information about the circuit breakers, and the circuit breaker state is closed. So I'm going to go back to my IDE and I'm going to stop the inventory service. So the inventory service is now stopped, and let's try to make a call to the order API one more time. So I'm going to send the request to the order API one more time, and you can see that we have received the fallback error message, and I'm going to first check the actuator health. So actuator endpoint, I'm going to refresh, and you can see that the state is still closed. So I'm going to execute this command one more time, execute this API call 4 more times. 1, 2, 3, 4, 5, right? We have executed 5 times, and quickly I'm just going to refresh, and you can see that our circuit breaker is already changed to the state of off open, right? So the circuit breaker will stay in open state only for some time, like we have configured to stay in open state for how much time? So it's for 5 seconds, right? I think we are too late. After 5 seconds, it's changed the state of the circuit breaker from open to half open, right? And now you can see that what you can do is let's start the inventory service. And after starting the inventory service, once it is up and running, just make sure to leave that inventory service for 30 seconds because it will take 30 seconds to register the inventory service back with the Eureka server. So I'm just going to leave this inventory service for 30 seconds so that it will warm up and just send the request to the Eureka server. And after 30 seconds, let's try to request the order endpoint one more time. Okay, after 30 seconds, I started placing the calls again, and now you can see that we have received the response order placed successfully. And if I open the health endpoint and refresh, you can see that the status is still in half open. Now let's try to make some more calls to place the order. And you can see that we have made more than 3 calls here. So now let's see whether the status is changed to closed or not. And you can see that the status is changed from half open to closed. Right. So in this way, we can implement the Resilience4J in our library and the circuit breaker design pattern in our project. All right. So now let's go ahead and implement some advanced use cases. Now we saw how our Resilience4J library will handle requests when the inventory service is not up and running, right? When the inventory service is down. So now let's also try to simulate the slow network connection case, right? So imagine that our order service is calling the inventory service, and for some reason the inventory service is not communicating, like not responding in time, right? Maybe it's slow due to a database performance issue. So how will Resilience4J can handle this situation? We can introduce a timeout, right? That means order service will wait for the inventory service response for a certain duration of time, maybe 5 seconds or 6 seconds. And if the inventory service is not responding even after 5 seconds, it will terminate the call. It will not wait anymore, and it will just throw a timeout exception. So to implement the timeout, we can open our IDE, and we just have to add some properties in our application.properties file. So this is going to be Resilience4J timeout properties. I'm just going to type in resilience4j.timelimiter.instances.inventory, right? And I'm going to provide the timeout duration as 3 seconds, right? So we want to wait a maximum of 3 seconds before terminating that call, because maximum of 3 seconds before terminating that call and throwing the timeout exception, right? So to implement the timeout, I can open the order controller class one more time, and all I have to do is I'm going to add an annotation called as time limiter. So this is again coming from the Resilience4J library, and the name I'm going to provide it as inventory, right? So one important thing we have to remember is like you have to provide the same name inventory as you've provided inside the properties, right? So after instances, we can provide some certain key, right? You need not provide only the name as inventory. You can provide any name you like, but just make sure that you use the same key inside the annotation, also the name attribute. So whatever attribute you have added here, you should also add the same attribute inside the name property for time limiter and as well as the circuit breaker annotations. So after adding the time limiter annotation, we also have to change the method signature of the method. So instead of returning a string, we have to return a completable future of string, because this will make an asynchronous call. We have to return a completable future. So I'm also going to change the return type of the fallback method to return a completable future. Instead of returning just a normal string, I will be providing completable future dot supply async, and then I will add this string here so that it will return the string. It will execute this logic inside a new thread and it will return a completable future. We also want to do this same thing inside for the place order method. So I'm just going to copy this message, order placed successfully. So we can change the return type of the place order method to return a string instead of void. So I'm just going to change the return type as string, and I'm just going to scroll down, and just after the save method, I'm just going to add the return statement as order placed successfully. Right, so this place order method is now returning the response string as we expect. And let's go back to the order controller method, and now I'm going to execute this place order method in a separate thread. So for that, I'm going to type again completable future dot supply async, and I'm going to call the place order method from inside this supply async method call. Right, I'm just going to return this particular completable future back to the method, and in this way we can implement the timeout. So this place order method will be executed in a different thread, and whenever the timeout is increased, like whenever the time limit has increased, it will just throw a timeout exception. Right, so to be able to reproduce this slow behavior, we also have to change the logic inside the inventory service. So for that, I'm just going to open the inventory service, go to the inventory service class, and inside the isInStock method, I'm just going to add a log statement. So for that, I'm just going to add the SLF4J annotation. I'm going to type log.info wait started, something like this, and another call as wait ended. Alright, so now I'm going to simulate a slow behavior here. So for that, I'm just going to add thread.sleep, and I'm going to call the thread.sleep method here with a timeout of 10 seconds. So here the execution will stop for 10 seconds and it will then start executing the remaining logic. So in this way, we can actually simulate a slow behavior inside the inventory service. And the sleep method is going to throw an exception. So for that, we can make use of sneaky throws exception, just so that this exception will be consumed. Don't use this sneaky throws exception in your production code. I'm just adding it for this demo purposes. Usually in the production code, you should be able to catch this particular exception and rethrow this exception. Okay. So now, as we have simulated this behavior, what I'm going to do now is I'm going to restart my order service and the inventory service. Right. So go ahead and rerun in debug mode, and also the inventory service I'm going to rerun in the debug mode. So once these two services are started, again, just make sure that you provide 30 seconds, you wait for 30 seconds until the service is visible inside the Eureka server. And then let's try to place an order and see how this is going to behave. So now I've opened the Postman client, and just make sure to access a new token when you're making this new call. So I'm going to click on the send button for the place order API post call method. So let's click on the send button. And you can see that we are getting a 500 error. So let's see what is this error. And yeah, you can see that we are receiving a timeout exception, right? So that means the order service is waiting for approximately 3 seconds before throwing a timeout exception. But here you can observe that in the inventory service, you can see the log wait started, and after throwing the timeout exception, this log of wait ended is printed, right? So let's try this. Let's see this one more time. I'm just going to clear the console also inside the order service application, and I'm going to send this request one more time, and let's wait until we get the exception. So okay, I'm going to open this logs, and you can see that we are seeing the wait started log, and after some more seconds we saw the wait ended log, right? And meanwhile, as the response is taking more than 3 seconds, like more than the timeout duration, our order service has terminated the call, and it threw the timeout exception. It's not able to, and it's not waiting for the response from the inventory service anymore, right? So in this way we can implement the timeout using Resilience4J library. So now we are going to implement another use case, that is retry, right? So whenever there is a slow response, or like whenever there is no response coming in from the target service, we would ideally like to retry the call, right? Like in this case, we would like to retry the call to the inventory service is in stock endpoint, right? So now we are going to go ahead and implement the retry mechanism, how to do it in the Resilience4J library. Alright, so to implement the retry mechanism, I'm going to open the application.properties file of the order service, and just below the properties for the timeout, I'm going to add a new comment, Resilience4J retry properties, and I'm going to type in resilience4j.retry.instances, and I'm going to call the inventory property, and I'm going to define the max attempts as 3. That means we have to attempt the retry for 3 times, and after that I'm going to again call the same property, inventory.wait duration would be 5 seconds, right? So we have to wait for 5 seconds before retrying this particular call, right? So if we don't receive the response in 5 seconds, we will just do a retry for 3 times. And if this retry is still not working, then we will just let the circuit breaker handle the actual request flow, right? And after adding these properties, we need to add another annotation on top of our controller class. So I'm going to type at retry, and here I'm going to provide the name attribute as inventory, right? Similar to the circuit breaker and the time limiter annotations, I'm going to also provide the name as inventory, and the retry annotation is going to pick the properties which is defined with this key, and which is going to apply this configuration whenever it's retrying, right? So I'm going to restart the order service one more time. So I'm going to rerun in the debug mode, and after the order service is restarted, again let's make sure to wait for 30 seconds. So the order service application is now up and running. So what we can do now is I can go to the Postman client one more time, and let's try to request another new access token. I'm going to click on get new access token method. I'm going to click on the proceed button and click on use token, and let's try our luck whether we are able to trigger the retry mechanism or not. I'm just going to click on the send button, and you can see that it's taking some more time to actually get the response. So let's have a look at logs, what's happening here. So I'm going to open the inventory service log, and here you can see that already we are getting the wait started logs more than one time, right? And again it started printing the wait started log one more time, and finally it's printed the wait ended log 3 times, right? So that means the order service has tried to has tried to call the inventory service exactly 3 times with a wait duration of 5 seconds, and that's the reason why you see the timeout exception now. You can also have a look at these statistics, how many times the circuit breaker has restarted and how many times the circuit breaker has timed out. You can check this everything inside the actuator metrics. So I'm going to open the web browser and I'm just going to refresh here the actuator health metrics, and if I just scroll down, you should be able to see this, but not here under the health metrics. But let's go to the actuator endpoint. So just localhost 8081/actuator, and if you can just scroll down, you can see the metrics about circuit breakers. If you want to see the metrics about circuit breakers, we are actually interested in the events about the retry events, right? So if you just scroll down, you can see one object called as retry events. If I click on this particular object, so you can see all the retry events which are triggered by Resilience4J, right? So it's actually triggered the retry exactly 3 times. You can also check how many times the time limiter is triggered by the Resilience4J. So this is going to be time limiter events. Yeah, so this is the events which we have created exactly 3 times. There was a timeout, and all these events are registered here through the actuator, right? So this is it for this video, guys. In the next video, we're going to continue and implement much more interesting patterns in our microservices project. So until then, happy coding techies.